All right, folks, here's another example. We are going to identify all this important information about this polynomial right here. Let's go ahead and start off with the easy stuff. What's the lead coefficient here? Well, here's the lead term. And the number, what's in front of that x to the fifth power there? There's a negative there. That means -1. So the lead coefficient here is -1. All right, what is the degree of this polynomial? Okay, the degree is the highest power of the polynomial. And the highest power of this polynomial is 5. And so this is a fifth degree polynomial. So we're going to put a 5 here. And then another really easy one is the Y-intercept. What is the Y-intercept of this polynomial? Where we're going to go all the way to the end. And the Y-intercept is positive 72. So we're going to put 0 because the x is 0, but the y is 72. There we go. All right, well, that was easy. We're 2/3 done. Maybe not. All right, now, in order to identify the roots and the factor multiplicity, we need to put this polynomial into factored form. Now, in the last video, I went ahead and just put it in factored form for you. But in this video, we are actually going to go through the whole thing. We're going to do the rational root theorem, the factor theorem, and everything. Okay? So in order to do the rational root theorem, we want to take all the factors of the last number. Those are the p's. So that's 72. So that's a long list of p's, am I right? Now the good news is we don't have a very long list of q's. Our q is just 1, right? So really we just have 1. So really we're just putting all these numbers over 1, which means those numbers themselves. Okay? All right, so we've got all of our possible rational roots. Are we going to test them all? Well, yeah, well, we're probably not going to have to test all of them. But here's the interesting thing. Now that we're introducing multiplicity, I need to teach you about a very kind of annoying quality of multiplicity. Let's start testing our numbers. We're going to test 1. And this is going to take a few minutes. And listen, I understand that this is going to take a few minutes. This could take 10 minutes. It could take 12 minutes. I'm probably only going to give you one of these on the test. So, you can relax and you can deal with the fact and just work through it. That's just the way life is sometimes. You just set you set yourself to the work and you do the work and you don't stop until it's done, okay? Over the summer, I had to replace some siding on my house and we had to get done one day and our attic was exposed to the elements and we just had to keep working. We wound up working, I think, from 7:30 that morning until about 10:30 that night. And even when I was done at 10:30 at night, I still had to fix some electrical stuff in my house because that's just the way it is. When you have work to do, you just do the work, okay? So, anyway, just do the work. All right, so we're just going to try all these numbers. We're going to put a 1 in. We've got a -1. And then look, there's no fourth power polynomial, so we have to put a 0 in. We've got a 15. We've got a -10. We've got a -60. And we've got a 72. Times 1 is -56, and I can stop there. That's not going to be 0. So if it's not 0, then it's not a factor, okay? So we're going to knock 1 off. So now let's try -1. Times -1 is positive 24, minus 60 is -36, and times -1 is not going to be 0, so I know that it's not -1. All right, let's try 2. Try positive 2 here. Put a 2 in the half box. 24 and -60 is -36. -36 times 2 is -72. This is good. We have our first remainder of 0. That means that 2 is one of the roots. So we know that 2, 0 is one of the roots because when we plug 2 into the polynomial, we get an output of 0. So we know that the point 2, 0 is one of the roots of this polynomial. That means that one of the factors is x minus 2. Now here's what I was saying before. We've now broken this down to a fourth power polynomial. We now have -x to the fourth minus 2x to the third plus 11x squared plus 12x minus 36, right? That's our new polynomial. And what I'm telling you is this, is x minus 2 might be a factor more than once in the polynomial. Therefore, we have to try it again. Every time we identify a factor, instead of just moving on to the next number, we actually have to keep trying that number until it doesn't come back. Okay? So we're going to put 2 in the half box again, but now we're going to use these new numbers. We're going to use -1, -2, 11, 12, -36. And we're going to do synthetic division with the same number on a new polynomial. We've taken out x minus 2. We have factored x minus 2 out of this, and now this is what remains. Okay? Plus 12 is 18. 18 times 2 is 36, with a remainder of 0. Wow, look at that. We have discovered another x minus 2. Now, we are not going to put it in the list of roots again. We're going to leave it as, because you can't, a function can't go through the same point twice. It only goes through one time. However, what we can do is go down here and write x minus 2 again. And what this means is x minus 2 times x minus 2. Isn't that equal to x squared minus 8x? Excuse me, that's not right. Minus 4x plus 4, right? And that means that that's a part of this polynomial. It means that that factor, x minus 2, shows up at least twice. But here's what we have to do. We got to try it again. As long as we keep getting a 0 for a remainder, we have to keep trying that number again. And we're going to keep trying 2 until we don't get a remainder of 0. Plus 3 is -9. -9 times 2 is -18. And sure enough, look at that. We got another remainder of 0. What that means is there are 3 x minus 2's in this function. This function is made up of x minus 2 times x minus 2 times x minus 2. All right? And what that leaves here is -x squared minus 6x minus 9. And now this can actually be factored. If you want to go ahead and factor this, when we factor this, there's a negative here. What's my first rule for taking out a common factor? If your lead coefficient is negative, you factor out a negative. So the only thing we can take out is a -1. So we're going to factor out -1, and that's going to leave us with x squared plus 6x plus 9. So I'm going to go down here, and I'm going to put a -1 here. See, this equals. I'm going to put a -1 in parentheses. So I've taken a -1 out, and now this can be factored. This x squared plus 6x plus 9. This is a special case. This is where if you take half of the middle and square it, you get this number over here. Another way to think about it is, what two numbers multiply to 9 but add up to 6? +3 and +3. So +3 and +3, put an x in front of each one, and you get x plus 3 times x plus 3. Those are the last two factors. How many factors could this have? Well, go to the degree. Whatever you have for the degree, that is how many factors you could have. And sure enough, 1, 2, 3, x plus 3, x plus 3. We're not counting the whole number, or the integer at the beginning, the non-variable, the constant term. Constant factors, they don't count in this. Okay? So we've got 1, 2, 3, 4, 5 factors. And we're done. We don't even need to look through any more of this list. And what 0 goes along with -3, or with x plus 3? It's -3, right? Well, there it is in the list right there. We would have eventually found that if we had kept going with synthetic division. All right? So now we have all of our factors. We need to identify all of our roots. We have to set all of these factors equal to 0. Well, we already did this one. X minus 2, x minus 2, x minus 2. When you set that equal to 0, you get x equals 2. That's the point 2, 0. Well, we already wrote that down as a root. So what about x plus 3? Well, we just showed you that up there. It's -3, but let me prove it to you. If I do x plus 3 equals 0, subtract 3, and we get x equals negative 3. That's the point, negative 3 and 0. And so we only have 2 roots. Even though we have 5 factors, we only have 2 roots. And you're going to see why in a second, or you're going to see how we're going to explain that. Now we're going to go to factor multiplicity. How many times, or how many factors do we have? Well, we have 5 factors, but really we only have 2 factors. We have x minus 2 and we have x plus 3. So we have x minus 2 and we have x plus 3. And here's the thing. How many times does x minus 2 show up? Well, it has a multiplicity of 3 because there are 3 x minus 2's. How many times does x plus 3 show up? It has a multiplicity of 2. It shows up twice. Okay? And I want to show you how we can actually rewrite this. Instead of writing it like this, what we can write is negative. The negative 1 just means that the whole thing is going to be negative. So f of x is negative. And instead of writing x minus 2 times x minus 2 times x minus 2, what do we do when we multiply something by itself 3 times? Don't we put power of 3 on it? So we're going to write x minus 2 to the 3rd power. What happens when we multiply something by itself twice? Don't we put a 2nd power on it, squared? So we're going to write x plus 3 squared. And this is the correct function, or the correct factorization of this. It has a degree of 5. It has a lead coefficient of negative 1. It has a y-intercept of 0, 72. There are 2 roots, 2, 0, and negative 3, 0. 2 x-intercepts. And then lastly, the multiplicity, the 2 factors are x minus 2 and x plus 3. X minus 2 has a multiplicity of 3, and x plus 3 has a multiplicity of 2. And now we've identified all of the qualities of this polynomial right here. Okay? I'm going to do one more video with one more example, and I think that you should have a much better understanding of this. Now, listen, you have to do these. Okay? You can't just stare at it. If you don't understand everything I just did, watch the video again. Watch the video again. Watch the video again. Okay? Sometimes that's what it takes.